So I'm going to spend what's going on, my seventh grader students and possibly parents who are joining in on us. Um, I'm going to ask this question up front. Is there any parents who happen to be joining in on us? I can't see your names because you're probably logging in on your student account. But all right. Well, it looks like not a whole lot of parents are joining us. That's fine by me. I just wanted to give the parents an opportunity to ask questions about the super long email that I sent out. But I'll go over the super long email that I sent out really quickly, and I know that you folks have read it, or at least hopefully you've read it. We're going to be participating in the Science Olympiad. The Science Olympiad is coming up on February 20th, 2016. It is a Saturday event. What I'm going to be doing, and then I also ask the parents if there's any parents out there who's really interested in science and engineering and helping out with those kinds of things. That way they can offer their help, because I'm not very good at, I'll be honest with you, I'm not very good at astronomy. I know a lot of the theory of it, but I don't know where to find the stars out all of that stuff. Yes, I'm archiving this as we speak. All right. So although I'm a great physicist, I'm not necessarily a great astronomer. We'll be building a bridge out of different kinds of wood, and I could use some help with the woodworking. Maybe some parents are really good at construction and woodworking and that kind of stuff. Here's the events that we will be participating in: air trajectory, astronomy and anatomy and physiology, bottle rockets, bridge building, disease detective, dynamic planet, invasive species, meteorology. Picture this: reach for the stars and write it, do it. Wait, my dad is, your dad's good at woodworking. Awesome. We might need your dad's help for some, when we're building the bridges. That would be good. Both of your dads. Yeah, that would be awesome. All right. Okay, so here's the different events that we will be participating in, and since the Science Olympiad events align pretty nicely with the curriculum that we're doing. What I want to do is I want to give everyone in the class a little bit of a taste of each of these subjects. But that doesn't mean that everyone in the class has to participate in the Science Olympiad. That's awesome that your dad's a flight engineer. Maybe we can talk about the different air trajectory things that your dad might be able to help out with. That'd be pretty cool. Okay, so there's different events that I have set up, like, for example, Write It, Do It, and Dynamic Planet, air trajectory. Right now we're covering air trajectory, and I'm teaching you not everything I know, but everything you might need to know for the event of air trajectory for the Science Olympiad. And why are there so many quizzes? Well, actually, these quizzes are labs, and they're my way of being able to help you guys help you guys learn these topics through labs. And so the reason why there's so many quizzes is because actually I'm trying to make a lot of labs, and the labs are actually a fun way of learning these things. So I'm doing a bunch of small little labs to teach you guys how to do these things, and I'm going through each of these labs with you. So that's why there's so many of these quizzes, and it feels like they're so overwhelming. It's because I want you folks to be able to play a lot with these different assignments. Got it? Okay. So the stuff we're going to be doing at the beginning of this month is we're doing air trajectory, bridge building, and bottle rockets. You guys were asking about the 3D printer, and actually, yes, I actually did get permission to use the 3D printer. And so what I'm going to do is, one of the things we're going to be doing is we want to use a 3D printer, but so I'm going to use a 3D printer when we're doing the bridge building design, because I think that would be pretty cool. Now, what we're going to do is we're going to I'm going to show you folks how to use or how to design a bridge. And then what we're going to do is we're going to use an engineering program to analyze that bridge. And then I'm going to show you folks how to draw things in 3D, and then you guys are going to build your bridge in 3D. No, it's going to be made out of plastic because that's what the 3D printer does. And then we're going to break the bridge, and we're going to see which design makes the best bridge that we would need. Got it? And then we're actually going to build that bridge out of wood once we've used the 3D printer to test out all the different kinds of designs we want to make. Does everyone get to use it? The answer is no. I'm only going to choose the 5 best designs or the 6 best designs. The 6 best designs from the class to print up. I'm not going to print every single one person's bridge. I'm only going to choose the top 6, and then we're going to test them out. All right? Can you do it in groups? I need to think about that. That might be a good thing for us to do. Maybe make it optional to do it in groups. I don't know. Some of you guys didn't like working in groups, and some of you guys really did like working in groups. It's up to you. I'll figure that out, and that might be a good thing. All right. We're also going to do bottle rockets, and I don't know if you've done this before. Have you guys ever used the bottle rocket that is, let's see, let's look it up. Water bottle rocket. Okay. You guys ever built this kind of rocket? Yes, 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 yes. All right, so, no, okay. So what this is this is a water bottle rocket, and basically you take a soda bottle, like a 2-liter soda bottle, and you fill it up with water, and then you pump it full of air and have it high pressured, and then you basically pull the pin, and it shoots off into a nice rocket. Well, what we're going to do is we're going to attach an egg astronaut to the top of this thing. And the goal is to get this egg astronaut to stay in the air as long as possible, but not crack, not die. So, you want your rocket to go as high as possible, but you don't want your egg to crack. So we need to kind of balance out those kinds of things. Anyway, that is kind of the idea of this whole thing that we're going to be doing. Some of the dates that are coming up is this coming Wednesday, we're going to be starting our bridge labs. On November 4th, we're going to have our first 3D bridge competition. So basically by then, you guys will have designed a 3D bridge. We'll have printed it out, and then we will, on the 4th, we're going to break the bridges. I think that would be really cool. On the 11th, that's actually a holiday, but yeah, I need to ask if we can come in. But on the 11th, we're going to go to Mililani High School and test out all of our bridge, or all the things we designed to see how we would fare inside of the actual thing. And yes, I am recording this. All of us, I don't think all of us are going to be doing the Mililani Invitational or the actual competition, but maybe the people who wanted to see how their bridge would fare on that thing. So for the next couple of weeks, there's a few lab materials that I want you folks to gather. I want a meter stick, a Nerf gun, wood, the wood to build a Nerf gun stand, and this one's actually kind of optional. A door hinge, definitely want one of those. Empty soda bottle, 2-liter egg, or a 2-liter egg, a grade A egg, and various other recyclable materials, and also a small amount of Legos, Connects, Lincoln Logs, and all that kind of stuff. Does anyone not have Legos or Connects in their house? It only needs to be like 10 to 15 pieces. Quinn, you don't have anything that you can use to build something? Yeah, Duplo is actually good too. All right. Yes. I was wondering about who does not have the Legos. Okay. Looks like everyone has lots of Legos except Quinn. I'm sorry, Quinn. Don't mean to single you out there. All right. All right. All right. I was just wondering because we're going to be using that for the Write It, Do It class. Now, we also have there's let's see, what else do I want to talk about? Oh yeah. Look, our class isn't going to be all of these fun things that we're just actually, you know what? I love having fun with you folks. But our class isn't only going to be these fun, different kinds of labs and that kind of stuff. We also have actual curriculum that we need to get through and different biology things that we need to cover and different anatomy and physiology and shark dissections and all of these other cool things that we need to cover. But the reason why it seems like I'm only focusing on the Science Olympiad stuff is because I want to make sure to cover these 3 topics first. And that's air trajectory, bottle rocket building, and bridge design. The reason being is because those ones require us to build something. Got it? And building always takes a long time. So, since we need a long time to do the building things, I'm starting off with things. You guys didn't realize how long the filter fest took us. It took us the whole quarter just to build one of those filters things. You know what I mean? All right. So with that said, are there any questions? Eric, you had a lot of questions that you want to ask. Lauren, you're confused about the whole thing. And actually, Lauren, I think that I'm going to go over all of the topics that you are confused about today. Right now, after I'm done answering the rest of the questions, I am going to be covering what you're confused about. So hold your questions off. Julian.
Wait, Mr. Saidi.
Actually, I'm not Mr. Saidi. I'm Mr. Dalde. Julian, we're not going to be using the Nerf guns in our lab on Wednesday. But maybe what you could do is bring in some extra Nerf guns and let some students who don't have Nerf guns borrow them. All right, Eric, was that you who's talking to me?
Wait, can you guys hear beeping?
Wait, hold on. Okay.
Sorry.
Or is that Michael? All right. Does anyone have any other questions? All right. Michael, what's your question?
Oh, okay. My question is, can you just type it to me? Because I can't really hear you because my computer is just beeping.
I don't know what you mean by type it to you. I'll record. I will. I don't know what you mean.
No matter what. But it means like wherever I am, my computer's just beeping.
Okay. All right. I'm going to turn your mic off, though. All right. I'm recording this. I will make sure to post this up to YouTube. And that's... I don't hear any beeping on this side, so... All right. Dude, turn your mic off. All right. Eric, what was your question? You guys had a question to me. You were asking me about recording something on question 12 or something like that? All right. All right. There was a video I made for question 12. Was there? I don't remember. All right, let's see. Let's look. And yes, Isaiah, what's up? What did you want? All right, here's the air trajectory quiz, and we actually made a video at the top, and I put it into the thing, and I covered all of the topics. Now, you're asking about question 12, which is here. Oh, okay. A lot of you folks were asking about the measured time, right? A lot of you folks were asking about the measured time versus the calculated time. Okay, here's my answer. The measured time, I mean, I don't mean to be obvious on this, but the measured time is the time you would get that when you measure it. Like if you use a stopwatch and you timed it, that's your measured time. Your calculated time is the time that you would have gotten if you calculated, if you used an equation. For example, the calculated time would be multiply the height times 2, divide that by gravity, and then square root that answer, and that's your calculated time. So there might be a difference between your measured time and your calculated time. And that's actually always a really interesting thing to look at, because the calculated time is what the theory says versus the measured time is what your actual hands measure. The problem is maybe your hands don't measure the same as what the theory says. And to see how far off you get, that would be a good question. Did I answer the question? Did I answer your question, Eric? All right, cool. I'm going to stop this video and I'm going to record another video